Do you feel ignorant because you don't know numbers? You don't know which one go which way and they got all these marks and things on them? I know, honey, it's hard, but there is a solution. Fort Bend Tutoring. And now here go Mr. Whit. Explain math to us, Mr. Whit.
Hello, ladies and gentlemen. This is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about how to graph a quadratic equation. That's right, aka a parabola. Yeah, a parabola. Okay, yeah, funny word, right? That's right, parabolas, the U-shaped graph. So here's one of the forms that you'll commonly see when you're dealing with quadratic equations, and that is y equals to ax squared plus bx plus c, and this is a vertical parabola, meaning that the parabola, the U-shape, will be pointing up or it could be pointing down. We're going to be focusing today on quadratic functions, which means we will not be dealing with horizontal parabolas because those horizontal parabolas are not functions, okay? So going back to our equation here, this ax squared plus bx plus c form, you'll note that anytime you have an a value that's positive, your parabola will point upwards. And since it's pointing up, you'll have a minimum value here. Also, if your a value is negative, it'll be pointing downwards. That's right, the parabola will point down as you see here in the diagram. And because of that, you'll have a maximum value. That's right. Then, anytime that you're looking at the absolute value of that a value and it's greater than 1, you'll have what is called a vertical stretch. It'll be a narrow U shape, okay? And then, anytime that value, that absolute value of a, is greater than 0 but yet less than 1, that's right, anytime you end up with a proper fraction as an a value, you'll end up with a vertical shrink. In other words, you'll have a very wide U shape there, okay? The most important point that you want to find when graphing a parabola is the vertex. That's right. You want to find out that minimum value or that maximum value. You want to find out the very bottom of that U shape or the very top of that U shape, depending on which way it's going to be pointing. And there's a formula for that. That's right. It's h equals to negative b over 2a. In order to find the k value, you'll just simply plug in that h value into your original equation. So note that we're labeling the x value of the vertex as h and the y value of the vertex as k. So anytime you see hk, it's representing a vertex of a graph, or it could also be representing the center of a graph. So this is very common when you're graphing functions and conics and other things that we'll be discussing on our YouTube channel, Fort Bend Tutoring. All right. Also, there's an axis of symmetry that you can also plot, and that is always going to be x equals to h. All right, so that's the most common form that you'll find, ladies and gentlemen, when you're dealing with a parabola. But you'll also find this form, which is called the vertex form. All right, and for the vertex form of a vertical parabola, you'll have it in the form of y equals to a times the quantity of x minus h squared plus k. Remember that that h and k value make up your vertex. So anytime you have your equation written in this format, it's going to be easy for you to find the vertex. Without doing any strange manipulation of the equation, you could just simply grab the opposite of that value inside the parentheses and that k value to come up with your vertex. All right, everything else here is going to remain the same. If the a is positive, it points up. If the a is negative, it points down. All right, so keep those things in mind, ladies and gentlemen. I'm just going to scroll up and down here so you can see all of the information that I have. Yeah, okay, there we go. All right, now continuing on. Let's continue on here. Here we have the parent function of a quadratic equation, and a quadratic function for that matter, and it is y equals to x squared. That's right, y equals x squared. And so if I want to go about the business of finding out what this vertex is going to be, all I have to do is recognize that here in this form, I have y equals to x squared. I don't have an x term, and I don't have a constant here. So I could expand it to show that this is actually x squared plus 0x plus 0. If I'm going to find out my h value, in other words, that x value of the vertex, then I should note that my b value here is 0. So here I just have 0 in the numerator. All right, it's non-negative and non-positive, so that negative b value is just 0 for this equation. And in the denominator, it'll be 2 times my a value, which here is 1. So that means that my x value of the vertex is just going to be 0. That's right. Then in order to find out the k value of the vertex, then all I have to do is plug in 0 into the original equation, and 0 squared is still going to be 0. So that means that I have an h value of 0, a k value of 0, to tell me that my vertex is 0, 0, aka the origin. All right, so that's good to know. From there, we're going to take that vertex, ladies and gentlemen, that 0, 0 value, and we're going to find 2 points to the left of that origin and 2 points to the right of the origin. In other words, since I found out my vertex and I know this is going to be a U shape, I want to go ahead and graph this U by utilizing the vertex as well as 2 points to the left of the vertex and 2 points to the right of the vertex. And so how do I do that? I start by placing my vertex in the middle of my XY chart, and I'm going to come up with 2 additional values to the left and the right. I'll have -1 and -2, as well as 1 and 2 to plug into the original formula. All right, so that being the case, ladies and gentlemen, when I plug in -1 back into our original equation, y equals x squared, -1 squared is just going to be 1. So I end up with a 1 value here for -1, and you know what? When I plug in +1, I'm going to get that same y value of +1. Then when I plug in +2, 2 squared back in the original equation is going to be 4. So I have a value of 4 for y here, and I have a value of 4 for -2 there because the negative squared will also give me +4. So notice how once we have that vertex there in the center, as we move equidistant from the vertex, our y values will be matched up. Okay, so that's good to know, right? Okay, good. So let's go ahead and grab these 5 points here. I'm going to start with my origin, which is 0, 0, and then I have -1, 1. That gives me a point there, and then I have a point 1, 1. That takes me right there, and then I have -2, 4, and now I'm up here, okay? And then I have 2, 4, and that puts me right there. All right, great. And I'm going to change this ink because I think I want to do this in, what am I going to do it in? Let's do it in blue. Let's do it in blue. So going ahead and connecting the dots, we'll have the following graph. All right, all right, all right. There we go. Steady hand. Arrows on both ends because that points up to infinity. And there is your graph, ladies and gentlemen. Just like that. Yeah, that's your parent function. Y equals to x squared. And those are the points that I always use to graph that, ladies and gentlemen. I like to keep it simple. You know? All right, so this is going to be our graph of our parent function. Also, if you wanted to graph your axis of symmetry, remember that it's always going to be in the form of x equals to h. So our h value in this case is 0, so you end up with x equals 0. That means, ladies and gentlemen, that if you were to slice this in half, it would be done so using the y-axis. That's right. Your y-axis, in other words, x equals to 0, that vertical line is the line of symmetry, the axis of symmetry that will cut your parabola in two. All right, let's go ahead and move on to our second problem here. So in problem number 2, we have f of x equals to x squared minus 2x minus 2. And notice that our equation is in function notation. That's right. Instead of having y, they have f of x as a label, as a name for the function, ladies and gentlemen. So anytime you see f of x, g of x, h of x, it just simply means y. That's right, the variable y. So since I have it in our standard form, that ax squared plus bx plus c form, then I'm going to go ahead and grab the coefficients, that a, b, and c value from our function so that we can find out what the vertex is. Our a value is going to be 1 in this problem. We're going to have a b value of -2, and we'll have a c value of -2 as well. Plugging in those values, that a and b, into our h formula here in order to find out the x value of the vertex, we'll end up with -2 over 2 times 1, and this will give us a value of +1 for our h value. All right, then to find out what the k value is, you simply plug in 1 into your original equation. So I know that 1 squared is 1, minus 2 is going to give me -1, and then -1 minus 2 gives me a value of -3. So that means that my hk is going to be 1, -3. So this is going to be the vertex, ladies and gentlemen, all right? Then finding your axis of symmetry, you're going to have x equals to h. So therefore, our equation for the axis of symmetry is going to be x equals to 1. So that means, ladies and gentlemen, that at the vertical line, x equals to 1, that's where we'll be cutting this graph in half. All right, so I'm just going to put a dashed line there to show that's where my axis of symmetry is, which is the equation x equals to 1. Now, going back to graphing our parabola, we're going to start in the center of our xy chart over here with the point 1, -3. So let's go ahead and check that out. So I have a point 1, -3 here for my xy graph, and remember, we're going to find 2 points to the left of the vertex and 2 points to the right of the vertex, and you always want to make sure that your point points are going to be equidistant from the vertex. So that means that I'm going to simply just start out by backing up 2 places. So I'm going to use 0 and -1, as well as 2 and 3. So knowing that my vertex is going to be at 1, -3, on the x-axis I move 2 places to the left to use 0 and -1, and I also move 2 places to the right to use +2 and +3. Now that I have these values, I'm going to go ahead and plug them in to find out what the y value will be. So I'm going to start by plugging in 0. So plugging in 0 into our original function here, I'll end up with 0 minus 2, which leaves me with -2. So if 0 is going to be -2, that means that +2 will be -2 as well. All right, because those equidistant values, x values rather, will give us the exact same y values from the vertex. So next I'm going to be plugging in -1. Plugging in -1 into the original equation, I'll have -1 squared, which is 1, and then 1, this is going to become a +2 after multiplying -2 times -1. So we have 1 plus 2 is 3, and then 3 minus 2 is going to give me 1. So I end up with 1 for both +3 and -1, ladies and gentlemen, just like that. So now I'm going to plot these 5 points on our Cartesian plane here, on the rectangular coordinate system. So here, starting out at 1, -3, so at 1, -3, I have a point, and I also will have a point at 0, -2. I end up with a point at 2, -2, and then we also have a point at -1, 1, and we also have a point at 3, 1. Yeah, just like that. So we'll graph this by connecting all 5 points and putting arrows at both ends there, and there's going to be your graph. That's right. So notice that we have our parabola perfectly graphed with those 5 points from our XY chart. In addition to that, we have our axis of symmetry. That's right. The teacher is pleased. Oh yeah, I have all of my steps, all of my work showing how I got my vertex, how I found my axis of symmetry. Oh yeah, I'm good to go. Yeah, I really am now. Okay, so that's what you have there, ladies and gentlemen. Done and done. Okay, let's move on to the next problem. Moving on to the next problem. I know you're just ready for the next one. You're saying, Mr. Witt, but what will you do next, Mr. Witt? And I'm going to show you. Okay, so notice that this problem here, the function f of x is equal to the quantity of x minus 2 squared minus 4, is going to be in vertex form. Oh yeah, and it's a happy day for that, because when your function is already in function notation and in vertex form, it is the easiest way to find the vertex. Oh, you have no idea. Let me show you. First of all, our a value falls right before those parentheses, and since you don't see anything, that value is going to be 1. That tells me quite a bit. It tells me that, first of all, that my U shape is going to be the standardized U shape of every parabola. That's the first thing. There's no vertical stretch. There's no vertical shrink. It's just a standardized U shape that I always will graph. The next thing is that the A value being positive will tell me that my U will be pointing up. So I know that I'm looking for a graph that will be pointing upward, just like the regular capital U would look. Okay. Then from there, ladies and gentlemen, we're going to go ahead and find out the vertex, and I told you it's going to be easy, so let me just show you this. All you have to do is take the opposite value of what you find inside the parentheses. In other words, the additive inverse of -2, aka the opposite, is going to be a +2. So my h value is just 2. That's it. Yeah. To find the k value, it's always going to be that exact number that you'll find right there. In other words, it's -4. So already we have the vertex. Done. There's no calculating needed at all. It's just there in front of you. So you just grab it. Okay? Then if I'm looking for the axis of symmetry, remember the axis of symmetry is always in the form of x equals to h. And my h value is +2, which means that my axis of symmetry, that equation is x equals to +2. And that's it. All right, let's go ahead and graph that. All right, so x equals to 2 is going to be a vertical line going through 2. So we're just going to show a dashed line to show where our axis of symmetry is. In addition to that, we'll go ahead and get working on our XY chart, knowing that in the center of this, I'll have the vertex, which is 2, -4. And as I promised you before, all you have to do is move 2 places to the left of the vertex and 2 places to the right of the vertex to have a solid, uniform, perfect parabola. All right, so I'm going to be using positive 1 and 0 as well as 3 and 4. And let's find out what these y values would be that go along with the x values that we chose. All right, well, plugging in positive 1, 1 minus 2 is going to be negative 1. And negative 1 squared is positive 1. And then 1 minus 4 is negative 3. So I'll have a negative 3 for that 1. And since I'm equidistant from that at 3, I'll have a negative 3 there as well. Now plugging in 0, 0 minus 2 is negative 2. And then negative 2 squared is positive 4. And 4 minus 4, well, that's just 0. So I'll have 0 here, and I'll have 0 there. All right, I have 5 points. I'm done. Let's get to plotting here. Okay, so I'll have a positive 2, negative 4. Positive 2, negative 4, that's going to be about right there. And then I'm going to have 1, negative 3, that's going to be about right there. And then I'm going to have a 3, negative 3, that's going to be right there. You see that? You see that? You see that? And then I'm going to have 0, 0, that's the origin. There we go, there we go. And then I'm going to have 4, 0, and I have a point right here. All right, so we're just going to connect these 5 points, and if I can make my U pretty, I'll be happy. All right, so we're going to say that that's fine. Okay, yes, yours looks better than mine, but that's okay. That's okay. I'm happy with this. Okay, you're sending in comments saying how much prettier your parabola is. Thanks a lot. And I'm replying to you saying, okay, thanks for your comment. Okay, there you go. All right, so all that's done now. All right, just over there bragging. You're a show off. So anyway, yeah. So we have the parabola graph now. That was problem number 3. We're gonna be moving on now to our next problem, which is problem number 4. And so in problem number 4, we have y equals to 1/4 x squared plus 1. So what you want to note in this case, ladies and gentlemen, is that your a value is 1/4. And anytime that a value, the absolute value of it, is a number between 0 and 1, in other words, you have a proper fraction like this 1/4 here, you know that you will have a vertical shrink. All right? You'll have a vertical shrink in this case. So we're going to have a very wide graph. Okay, we're going to have a very wide graph in this case. And then my b value, we don't have an x to the first power term, so that b value will just be simply 0. And then your c value is 1. So this is getting the coefficients from the quadratic function here. All right, now to find our vertex, we'll be utilizing that formula. So notice that since we're not in vertex form, we will be utilizing the formula in order to come up with the vertex. So that means I'll be plugging in my values here. So a negative b is just going to be, in this case, 0 over 2 times this 1/4, and this equals to 0 over 1/2, which is still just going to be 0. Okay, so our h value is 0. So if you want, you can go ahead and show that your axis of symmetry is x equals 0, which is the y-axis, by the way. So I will go ahead and just show that with a dashed line on the y-axis. There we go. Going back to finding the k value, you simply plug in your h value, that x value of the vertex, into your original function. So plugging in 0 for x, you'll have just 0 plus 1, which is 1. There you go. That answers 1 for k. So that means that my vertex is going to be 0, 1. Yeah, just like that. That's the vertex, and that's the most important point that I need in order to graph my function here. Okay, so I'm going to start in the center with 0, 1. And remember, you're going to move 2 places to the left of the vertex and 2 places to the right of the vertex. So we end up with -1, -2, as well as +1 and +2. And then plugging in these values into your original function, you'll have the following. You'll have the -1 going in here. All right, so -1 squared is 1. And then you'll end up with 1/4. Okay, and then 1/4 plus 1 is going to be 1 1/4. All right, so we'll just plot it as 1 1/4. That's going to be the y value for both -1 and 1. Then if you were to plug in, let's say 2, 2 squared is going to be 4, and 1/4 of 4 is 1. So you'll end up with 1 plus 1, which is 2. So I have 2 for here and 2 for -2. All right, let's go ahead and plot those 5 points, ladies and gentlemen. We start at 0, 1. So 0, 1 is the first point, and then we also have -1 and 1 1/4, which is just a little bit above that. So I'm going to have that equidistant here at +1, and then at 2, I end up with 2. So it's going to have this over here, and then at -2 will be at +2 there. So notice how wide this is already. So we'll end up with this graph looking just like that, ladies and gentlemen. A lot fatter than the previous problems that we've had thus far. So this is the graph, ladies and gentlemen. That's it. So notice that once again, our axis of symmetry is that vertical line there, which is the y-axis, and I have my 5 points plotted defining my U shape, which is much wider because of my A value being a proper fraction. That's right, a value between 0 and 1. There you go. That's problem number 4. Continuing on. Alrighty. In problem number 5, ladies and gentlemen, we have the function f of x equals to -2 times the quantity x minus 1 squared minus 2. Now, if you're familiar with your transformations, ladies and gentlemen, they can apply to quadratic equations as well, which means that your original parent function will be shifted over one place to the right, and it'll also be shifted down 2 places because of the -2, and it'll be pointing down because you have a negative a value, and you'll have a vertical stretch, so that means that it's going to be a little narrower, that's right, skinnier than normal. But if you don't have to do it that way, you can just ignore all that and just say, hey, okay, I have a negative a value, it's -2, and I know that my vertex is going to be +1, -2, because you take the opposite value that you'll find inside the parentheses, because that's x minus h, that's x minus h. Since it's a negative h inside the parentheses, you want to use the opposite value of that. So we're going to use a +1. Then your k value is always exactly as you see it there, so you'll use a -2, and that's the vertex. It's just that fast. So if you're looking at speed, ladies and gentlemen, having your equations, having your functions already in vertex form is a lifesaver time-wise, okay? From there, your axis of symmetry is going to be x equals to h. So we'll end up with x equals to +1. All right, so let's see if we can draw a straight axis of symmetry, and that's pretty straight there. Okay, that's pretty good. That's pretty good. All right, then start in the middle with your vertex. It's going to be at 1, -2, and remember, you're going to walk 2 places to the left and 2 places to the right of your vertex. So I'm going to use 0 and -1. I'm going to use 2 and 3 for my x values, and then I'm going to plug them in. So let's start with 0. Plugging in 0 into your original function, you'll have 0 minus 1 is -1, -1 squared is +1, -2 times 1 is -2, and then -2 minus 2 gives you -4. So I have a value of -4 here for 0 and for 2. Then I'm going to be plugging in -1. -1 minus 1 is -2. -2 squared is going to be 4. 4 times -2 is -8, and -8 minus 2 is -10. So I have the values -10 and -10 there for y, for x equals to -1, as well as for x equals to 3. And these are the 5 points that I will plot, ladies and gentlemen. We'll start out in our center here with 1, -2. So at 1, I'm at -2 here. And then I have 0, -4. At 0, I'll be at -4. And then I'll have 2, -4. And 2 is -4 right here. And then, ladies and gentlemen, you'll have -1, -10, which is going to be off the chart. It's off the chart. It's way down there. It's way down there. Okay, look at the graph, stops at -6. It's going to be way down there. And then you'll have 3, -10 is going to be way down there. We'll just go ahead and project that to show that it's going to look like this. All right, arrows, arrows. And there you have it, ladies and gentlemen. That's the parabola. Notice how it's pointing down. That's right, it's pointing down because of our negative a value. All right, ladies and gentlemen, so that is problem number 5, just like that. Okay, coming up next. Okay, in problem number 6, we have y equals to -2x squared plus 4x minus 2. The first thing that stands out to me in this problem is that a is negative. So I know that I'm going to end up with a parabola, a U shape that points down. The b value here is going to be 4, as well as my c value, which is 2. Because it's in standard form here, I'm going to go ahead and utilize this formula for finding the vertex. So remember that h equals to -b divided by 2a. So plugging in my values here, I'll have -4 divided by 2 times -2, and this is going to give me a +1 for my x value. All right, and remember, that's the x value of the vertex. From there, plugging in that 1 into the original function here, we can end up with the k value. So 1 squared is 1. 1 times -2 gives me -2. -2 plus 4 is going to be +2, and then 2 minus 2 is 0. So we end up with a k value that's 0. All right. From there, ladies and gentlemen, I can go ahead and write my vertex as 1, 0. And also, I know that my axis of symmetry is always in the form of x equals to h. In this case, it'll be x equals to 1. So on my graph here, I'm going to go ahead and draw my vertical line at x equals to 1. And that's going to show my axis of symmetry. And your axis of symmetry is going to be a lot straighter than mine, because mine's a little lost in this area here, and I don't know what it's doing. Anyway, continuing on, we're going to start by placing the vertex right in the center of my XY chart. So I have 1 and then a 0. And as always, we're going to go ahead and move 2 places to the left of that 1 and 2 places to the right of that 1. And always make sure that your points are equidistant from the vertex so that it'll make a perfect U shape, okay? So here I'll end up with 0 and negative 1, and I'll use 2 and 3, just like that. So now I'm going to be plugging in 0 into the original equation. So I end up with negative 2 as a result. That's right. Yep. See, that term there zeroes out. That term, it zeroes out to leave you with just negative 2. Then I'll be plugging in negative 1. Negative 1 squared is going to be 1. Then 1 times negative 2 is negative 2. And then I end up with negative 2 and a negative 4. That gives me negative 6. And then negative 6 and negative 2 give me negative 8. So I have negative 8 here, and negative 8 will be at 3 as well. So with these values, ladies and gentlemen, we're going to end up with the following. Also keep in mind that since our A value was a negative 2, the absolute value of that is 2. And anytime you have an absolute value of A that's greater than 1, you're going to end up with a vertical stretch. So this graph should be skinnier than most of our other graphs, all right? So keep that in mind. All right, so we start out at 1, 0. So I have a point right here, and then I have 0, negative 2. That gives me a point right there. And then at 2, I'm at negative 2. So I'm right here. And then at negative 1, I'll be at negative 8. So that's going to be down there somewhere. And then at positive 3, that'll be down there somewhere. So graphing these points, my parabola will look just like this, ladies and gentlemen. Arrows on both ends. So we end up with a graph that's just like that. That's it. Okay? So that's the graph of problem number 6. And now, let's go ahead and check out our next problem. Problem number 7 is up, ladies and gentlemen. You got it. And we have vertex form. Yeah, that's right. I'm excited. Vertex form allows us to find a vertex a whole lot faster. So note that your A value is 1/2, so we know this is going to be a wide U shape. Then my vertex is going to be the opposite of my positive 3, so I'm going to use a negative 3 for the H value, and then the K value is just 1. So we're already at our vertex. My axis of symmetry, yeah, you got it. That's going to be x equals to negative 3, ladies and gentlemen. So that means I'll be having a vertical line right through negative 3 here in my graph. You got it. All right, we're going to start with our XY chart with our vertex in the center. I'm going to walk 2 places to the left of that center there. So I'm going to use negative 4 and negative 5. I'm going to use negative 2 and negative 1. And I'm going to plug these values into our original function here. So starting out, I'm going to plug in negative 2. Yeah, I like the small numbers. So negative 2 plus 3 gives me 1. And then 1 squared is 1. And then half of 1 is 1/2. So adding 1 to that, we'll end up with 1.5. All right. So I'll write that as 3/2. All right. Same value. Okay, then I'll be plugging in negative 1. So plugging in negative 1, negative 1 plus 3 is positive 2. 2 squared is 4, and half of 4 is 2. Add 1 to that, you get 3. So if negative 1 is 3, then my negative 5 will also be 3. Okay, so let's go ahead and take a look at our graph. Let's go ahead and plot these points. So starting out, I'm at negative 3, 1. That's my first point, goes right there. Then I have negative 2 and 1.5. So negative 2 and 1.5, that's the same value as 3/2, by the way. Negative 4, I'm going to also be at 1.5. And then I have negative 5, 3. That gives me a value here. And I also have negative 1, 3. All right, so there we have it, ladies and gentlemen. We have our parabola, just like that. So that completes this lesson on how to graph a quadratic function, ladies and gentlemen. That's right, a parabola. So hopefully that helps you out in your studies and also in your math classes. And as always, please rate, comment, and subscribe. And if you're able, ladies and gentlemen, please donate, because that helps us bring you more free math videos from Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? You could do all that on tutormemath.net.